So in this problem here, we're given a curve, and first of all, we're asked to find dy over dx. So simple differentiation, we don't have to rearrange anything here. Straight away, 6x squared minus 10x minus 4. It becomes a quadratic equation. Use the result to find the turning points. Another name for turning points is stationary points. All we do is make this equal to 0, because at the turning points, or at the stationary points, dy over dx is equal to 0. Now go ahead and factorize, but before that let's divide everything by 2 to make it easier. So it becomes 3x squared minus 5x minus 2 is equal to 0. Simple factorization, or use the quadratic formula if you wish, however the easiest way is for yourself. So we need two numbers that multiply to give these two multiplied, which is minus 6. So multiply to give minus 6, add to give minus 5. That's going to be minus 6 plus 1. So change this into those two numbers. So keep that the same, 3x squared minus 6x plus x minus 2 is equal to 0. So minus 6x plus x goes back to minus 5x. That's the same, and that's the same. Now factorize these two, so it becomes 3x, x minus 2. Copy and paste it here, x minus 2. What do you put there to make that go back to that? It's plus 1. If you expand that, it goes back to this. Then take one of these brackets, they're both the same anyway, always are, x minus 2, and take the remainder, 3x plus 1 is equal to 0. We've factorized. So the coordinates of the turning points are either x minus 2 equals 0, so x equals 2, or 3x plus 1 equals 0. Rearrange it, it becomes x is minus 1 over 3. These are the two x values of the stationary point. Plug these two back into your equation to find the other 2 points. Now the equation we have to plug it back into is this one here, the original equation, to find the y coordinates of these 2 points. So to find y1, we say okay, remember this is x1, x2, y1, we put x1 into there. So that's going to be 2 to the power 3 is 8, 2 times 8 is 16, put 2 into there, 4, 20, minus 8 plus 2. So in this particular case you have 16 minus 8, which is 8, plus 2, which is 10, minus 20 gives you minus 10. Let's find the other one, a bit more challenging because you have a fraction here, but we can go ahead and do it anyway. So y2, let's do it up here, is equal to 2 multiplied by, now we have minus 1 over 3, all to the power 3. It's going to be minus 1 over 27, minus 5, x squared. That's our x. To square that, it becomes a positive 1 over 9, minus 4 over 3, plus 2. Plug all these values in, and you get a y2 value of 1 over 27. So the coordinates are 2 minus 10 and minus 1 over 3, positive 1 over 27. Now, it says in this part here, find the second derivative, so differentiate that again. So the second derivative is equal to, multiply that by that, 12x minus 10. And then it says, determine the nature of the stationary points, or the turning points, so maxima and minima. All we do is take our x values, plug it into there. If it's positive, it's minima. If it's negative, it's maxima. So start by taking x1, put it into there. 2 times 12 is 24. 24 minus 10 is 14, which is positive. So the first one, x1, if it's positive, it's a minima. x2, we put minus 1 over 3 into there. It becomes minus 12 over 3, which is minus 4. Minus 4 minus 10 is a negative number. Therefore, the second point is a maxima.